All right, so we are going to look at 5-6. 5-6 is really no different than 5-5, but you're just putting it all together. And so I'm going to assume that you don't have a calculator. If I did have a calculator and I wanted to find my roots, I would use P over Q, plug the polynomial into the calculator, and look to see which roots might match anything I have on P over Q. But if I don't have a calculator, and that's what I want you to practice, if you don't have a calculator, what are you going to do? Because this is going to take you the longest on your test, is trying to hunt in the dark for something that you're looking for. So, fundamental theorem of algebra just says right here that if you have a polynomial of a degree greater than 1, so if it's a degree of 2 or higher, you have at least one complex root. Remember that complex root has a real part to it and an imaginary part, so they're just saying maybe you have a purely real number like 2. 2 is considered a complex number. It has a real part of 2 and an imaginary part of 0. If you have an imaginary number like 5i, that's a pure imaginary number because there's no real part to it. That is still considered a complex number, even though it doesn't have a real part to it. So don't get all caught up in that. All right, so for example, this polynomial here, highest degree of 3, has at least one complex root. We know it has 3 roots total, but they're just saying it has at least one. So it's kind of like, well, no duh, of course they do. And then on these 3 examples, they're all parabolas. Of course, this is what we mean by roots. So there's 2 real roots. And here, with it just sitting on the x-axis, we have 1 real root. And on this last one, it's not even touching or crossing the x-axis at all. We have 0 real roots. All right, so again, what procedure are we going to use in order to find all of our zeros? If you get stuck, just look here. So always, always, always start in standard form. Find your P over Q. So this is your P over Q. Then use synthetic division. You might even use Descartes' rule. And then continue to factor until you have, you use synthetic division until you have a quadratic, which means the second degree. And then take that quadratic and continue to factor. Either factor it or use the quadratic formula to get it down to all of its linear factors. Okay, so let's look at example 1. I'm going to make this bigger so we can all see what's going on. And straight, maybe, yep, there we go. Sort of, well, you know I can't see, so I guess that looked straight to me. Now that's better. Okay. All right, so the first problem with this one is we do not have it set equal to 0. It's not in standard form. So I am going to subtract 3x squared and add a 10x and put them in order. So standard order, step 1, I get x to the 4th, then plus 2x cubed. Then I move the 13x over, so I have minus 13x squared. And move the 10x over, so I have plus 10x equals 0. So normally I would start with P over Q, but I don't have a constant because they all have an x in common. So since they all have an x in common, I can actually use the greatest common factor and factor an x out. So I already know one of my roots is going to be 0. So I have x times x to the 3rd plus 2x squared minus 13x plus 10 equals 0. So now I only have to worry about finding my roots for this. So then step 2 is going to be P over Q. So P over Q equals. So remember, my 10 is my P, and so here's the deal. If I've got 10, all the factors of 10 over all the factors of 1, Aren't all the factors of 10 that are divided by 1 all the factors of 10? So I really don't see a need to list them all out, put them over 1, and then have to list them out again. So common sense just says that I'm going to have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. No fractions. So at this point, you could use Descartes' rule, but I really don't have that many to choose from, and I only need to find one. So I'm probably going to start with 1, -1, and 2. And if I don't get anywhere there, I mean, how much longer is it going to go? It really doesn't take you that long to do synthetic division. Okay, I am not missing any terms, 3, 2, 1, 0, so I don't need any placeholders. And root on the shelf. And I've got 1, 2, -13, and 10. I am going to try 1. It's one of my favorites. So I'm going to bring down the 1, and then I'm going to multiply through. So 1 on the shelf times 1 is 1, add down is 3. 3 times 1 on the shelf is 3, add down is -10. 1 times -10 is -10. Looky there. Didn't we just get incredibly lucky? And I swear I did not cheat by looking ahead. So I know for sure that I have one term, or one of my roots. So let me circle that one. Get pretty color. So here's one root. And now I have it down to a quadratic. And so my quadratic is x squared, because I started with an x cubed. Actually, I have 2 roots, right? Let's not forget about that root there is going to be 0. So circle that. We can't forget about that one. And then I have a plus 3x and a minus 10. So step 4, can I factor x squared plus 3x minus 10 equals 0? Are there factors of 10 that subtract to give you 3? Well, sure, it's 5 and 2. So x squared becomes x and x, and I know I have the factors of 2 and 5 that subtract to give me 3. My 3 is positive, so the bigger the 2, 5 gets the sign, so the 2 must be negative. So I have x equals 2 and x equals -5. And I am looking for a total of 4 roots, and I have found them all. So last step, step 5, is list your roots. So x is equal to, this one here, if I set it equal to 0, x is equal to 0. That was my first one. And then 1 from the synthetic division, and then from the factoring above. These are all 4 of my roots. Now that didn't take so long. Wasn't so bad. Let's look at the next one. All right, so example 2. If I were you, I would pause the video and try what we just did on your own and see if you can figure it out, and you might even test yourself a little bit. I will give you a little hint. You will probably have to, since we have x to the 4th, you'll have to use synthetic division twice, and you will end up with a quadratic. You'll probably have to use a quadratic formula. So if you do all that, you're on the right track. All right, pause the video, try it. Really, don't cheat, try it. All right, so hopefully you didn't cheat. And the first thing I'm going to do is find all of my factors of P over Q. So P over Q is equal to, so I have factors of 6 over factors of 2. So my factors of 6 are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, divided by my factors of 2 are plus and minus 1 and plus and minus 2. So if I divide all of these over 1, gives me everything in my numerator. So I get plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. Then 1 divided by 2 I don't have, so plus and minus 1/2. And then 2 over 2 I have, which is 1. 3 over 2 I don't have, so plus and minus 3/2. And then 6 over 2 I have, which is 3. So my only possibilities are these right here. So as I've said before, I typically won't try these. They're not fun to do, but I'm going to do synthetic division. I could use Descartes' rule, but I only really have 8 that I could possibly choose. And honestly, synthetic division does not take that long. So I'm going to use synthetic division. I've got to get my x to the 4th down to an x squared, so I've got to do it twice. And so this one will be an interesting one to see, well, how do I do it twice and how does that work? So am I missing any terms? 4, 3, boop, I'm missing 2. So I need to add a 0 for my x squared. So if you forgot that, that's probably where your mistake was. Sorry about that. So we have 2, -3, and then 0 for my placeholder, and then -1, and then -6. Okay, I'm going to bring down the 2. And, you know, I always like to start with 1. So I am going to put 1 on the shelf. 1. 1 times 2 is 2. Add down, I get -1. -1 times 1 on the shelf is -1. Add down, I get -1. -1 times 1 on the shelf is -1. Add down, I get -2. -2 times 1 on the shelf is -2. Add down, I do not get 0. So instead, I think I will try a -1. So I'm going to change the sign to a -1 and start all over again. So -1 times 2 is -2. Add down, I get -5. -1 times -5 is +5. Add down, I get +5. +5 times -1 on the shelf, I get -5. Starting to look promising. Add down, I get -6. -6 times -1 on the shelf is +6. Add down, whoop, there it is. So very exciting. I'm super excited. There's one of my zeros. I just have one more to go with synthetic division. Now typically I like to repeat the -1 because don't forget I could have -1, -1, -1. I mean, I could have double, triple roots. So I typically will like to do this again and use that same root just to exhaust the fact that it's done. But you do not start with this again. This is our new polynomial. So we're going to start with these numbers so we have a shorter synthetic division, which is nice. Now you could just put your new upside down division bar there, but I'm going to use a whole new one. So 2, -5, 5, -6. Okay, so if I try -1 again, now I know that 1 didn't work, so I'm not going to try that again, but -1 might work. So -1 times 2 is -2. Add down, I get -7. -7 times -1 on the shelf is 7. Add down, I get 12. I can see here it's not going to work because -1 times 12 is -12. And added to the 6 is not going to work. So scratch that. I'm done with my ones. And so this time, I'm going to move on to positive 2. So I'm going to use positive 2. Here we go. 2 on the shelf times 2 is 4. Add down, we get a negative 1. Negative 1 times 2 on the shelf is negative 2. Add down, I get 3. 3 times 2 on the shelf is positive 6. Add down, I get 0. Whoop, there it is. Another exciting moment in the world of mathematics. Can you tell I'm bored? Okay, it's late. It's now 9:30. Okay, so see what I do for you all. I am a dedicated individual. All right, so I have ended up with, I went from a x to the 4th here to an x cubed here to an x squared here. So I know for a fact I have 2x squared minus 1x plus 3. So all that's left is, can I factor 2x squared minus x plus 3 equals 0. So let's multiply. 2 times 3 is 6. Are there factors of 6 that add to give you 1? No, there are not. So we are left with a quadratic formula. So to save time, I'm not going to actually write out the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But you should know that. So instead, I am going to write out my template. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So a is 2, b is negative 1, c is 3. So I'm going to put a negative 1 here and a negative 1 here because that's my b. My a is 2, my c is 3, and my a down here is 2. So I have x equals 1 plus or minus the square root of, I end up with negative 23. Whoop, that means I'm going to have an imaginary root all over positive 4. And so this is equal to 1 plus or minus the negative comes out as an I. 23 is prime, so it stays underneath all over 4. So that's actually 2 answers, 2 roots. So there's my other one. And I'm going to circle that. So last step, list out your roots. So my roots are going to be x equals, my first root was negative 1. Now mind you, I have a total of 4. My second was 2. And my third and fourth, I'm going to put together 1 plus or minus I, square root of 23, all over 4. And so this is my final answer. I didn't time myself. It was a little bit longer than the previous one. All right, so this one's actually more fun because I don't have to guess and check too much. So I'm going to make it a little bit smaller. Find all the zeros of the function by factoring completely. So they're implying it's factorable into a product of linear factors. Well, I have 1, 2, 3, 4 terms. They all do happen to have a greatest common factor. However, I am not going to factor that out because it's 4 terms. And I already know, well, I'm going to go ahead and factor it out because it won't matter. So let's go ahead and factor it out because that's what I've taught you to do. So we'll do that first. So I'm going to factor an x out first because you're going to have to factor it out at some point and you might forget to factor it out at the end. So I'm going to pull that x out in front and I'm left with x to the third minus 2x squared minus an x plus a 2. Now see how I still have 4 terms, and when you have 4 terms you have to cut them in half, find the GCF of the first group and the GCF of the second group. You cannot forget about this x. Don't forget about it. So I'm going to use brackets for right now until I finish this up. So the GCF of the first group is x squared. That's a squared. So I'm going to pull out an x squared out in front, and I have an x minus 2 left over. The second group doesn't have a GCF, but the third term is negative. So remember, if that third term is negative, I want to factor it out. So I get a negative 1 times an x minus 2. And so then bring down the x, and then they have an x minus 2 in common. So this x minus 2 is getting brought out in front, and what's left over, x squared minus 1, is going to get thrown into the empty parentheses. Now you thought you were done. Not so fast. Isn't this the difference of two squares? So we will continue our factoring. So the x doesn't change. The x minus 2 doesn't change, but the x squared minus 1 will factor into the difference of two squares pattern of plus and minus. So the square root of x squared is x, and the square root of 1 is 1. And so now I am fully factored, and don't forget that this is equal to 0. And it says find all the zeros by factoring, so I'm not done, so I have to set x equal to 0, x minus 2 equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. So finally, all of my factors are 0. Whoops. Trying to put a plus or minus 2, but that would be inaccurate. A positive 2, a negative 1, and a positive 1. And since I started out with an x to the 4th as my highest degree term, it would make sense that I would have 4 zeros. Okay, so now that you've done quite a few, this is the very last one we're going to do for these notes. And so I want you to try it one more time, where you are going to look at this, find your p divided by q. You could use Descartes' rule to kind of help you, and in fact maybe I might do that with you, and then get this x to the 4th down to a quadratic. So you can either stop the video or continue with me, it's your choice. But step 1, I'm going to do p divided by q. So what's nice is that my p is 12 and my q is 1. So I know that all the factors of 12 are going to be over 1. So there's no sense in putting all the factors of 12 over plus or minus 1 and then listing them again. So again, my possible factors are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now because there's quite a few of them, there's 1, 2, 3, 4, 5, 6, there's 12 of them, I might use Descartes' rule just to help me along a little bit. So if I use Descartes' rule, I'm going to put that over here. I'm going to find p of 1. And so p of 1 would be I'm going to run out of room. And I'm going to squeeze it in here, plus 12. That's a weird 12, but it is a 12. 1, 1, 1, 1. So I would get 1 plus 4 plus 7 plus 16 plus 12. All right, do you see any sign changes here at all? Nope. And we have 4 roots. So out of those 4 roots, none, because there's no sign changes here, none are going to be positive. So they're all going to be negative or imaginary. So I'm not going to even finish Descartes' rule because I'm going to focus on negatives because I can't find imaginaries. So I'm just going to start with negative values. And remember, some of them could be double roots. So I'm going to go with synthetic division. And I'm going to start with my fave, which is negative 1. Am I missing any terms? 4, 3, 2, 1, 0. Answer is nope. So I get 1, 4, 7, 16, and 12. And then the root on the shelf we're going to try is -1, bring down the 1, and start multiplying. -1 times 1 is -1, add down is 3. 3 times -1 is -3, add down is +4. 4 times -1 is -4, add down is a beautiful 12, because 12 times -1 is -12, and whoop, there it is. I have found one of my zeros, so there's just one more to go. Now I would like to try -1 again, just in case. But remember, we're going to use this instead of this. So using 1, 3, 4, and 12. So if I use -1 again, I'd still bring down the 1. -1 times 1 is -1, add down is 2. 2 times -1 is -2, add down is 2, and there is no way I'm getting 12. So I might as well stop right here. So that's not going to work. Okay. So, boop. Okay. So instead of -1, because -1 is done. So once it doesn't work, then it's done. So I'm going to move on to, I could try -2, but the -1 didn't get me very far, so I'm going to try -3. If -3 yields too big of a number, I'll back down to -2. So I'm going to put -3 on the shelf, bring down my 1. 1 times -3 is -3, add down is 0. 0 times -3 is 0, add down is 4. 4 times -3 is -12, add down is 0, and there we go. So there is a second root, and I have now gotten us down. Whoops, I did not want to do that. Instead, okay, so instead I meant to choose a pen. So I've got x squared now plus 0x plus 4. So step 4 is going to be to factor x squared. There's no sense in putting a 0x plus 4 equals 0. So you could do this a couple of ways. You could either use the difference of two squares factor pattern, or you could subtract the 4 from both sides. It's your choice. It doesn't matter which, but I'm going to save room. So I'm going to subtract 4. I wanted in red. Subtract 4 and subtract 4. So I want to warn you about what happens, though, when you use the square root method. So remember, when I take the square root of both sides, don't forget plus or minus the square root of -4, because you've got to get two roots. So x is equal to plus or minus, the negative comes out as an I, square root of 4 is 2. So I have now found all 4 of my roots. So last step, step 5, is to list them out. And so x is equal to, the first one I found was -1, then I found -3, and then I found my two imaginaries for a total of 4 roots. And that's it. So it wasn't that much different than the 5-5. So good luck at your homework. Text me with questions. Have a great weekend.